Your logs vanish. Elasticsearch rejects documents, Logstash drops them silently, no errors, no Kibana data, no DLQ. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover ELK Stack. ELK is a data pipeline. Filebeat collects logs, Logstash transforms them, Elasticsearch indexes them, and Kibana visualizes them. Each component can fail independently, so understanding the flow is critical. Data flows from edge nodes through Filebeat, optionally through Kafka for buffering, then Logstash transforms it, and Elasticsearch indexes it. Kibana queries Elasticsearch for visualization. This Docker Compose file sets up a minimal ELK stack for local development. It includes Elasticsearch, Logstash, Kibana, and Filebeat. Note the persistent volumes for Elasticsearch data and Filebeat registry to prevent data loss on restart. The beats family are lightweight data shippers. Each beat is purpose-built for a specific data type. Using the wrong beat for a job leads to fragile configurations and maintenance headaches. Here are example configurations for each beat. Filebeat handles log files with multi-line support for stack traces. MetricBeat collects system and service metrics. PacketBeat captures network traffic. WinlogBeat collects Windows event logs. Heartbeat monitors uptime. AuditBeat collects security audit events. Elasticsearch uses an inverted index. When you index a document, it tokenizes the text and writes each term into a term dictionary that points to a posting's list of document IDs. This is why full-text search is fast. It's a dictionary lookup, not a scan. This demo shows how Elasticsearch tokenizes a document. The Term Vectors API exposes the inverted index directly. You can see each term, its frequency, and position. Searching for timeout uses the inverted index to find the document instantly. Each shard is a leucine index made of immutable segments. New documents go into a buffer, then are flushed to a new segment on refresh. The merge thread consolidates small segments in the background. Too many small segments can cause I/O storms and slow searches. Logstash pipelines have 3 stages: input, filter, output. The filter stage is where most CPU is spent, especially with Grok pattern matching. Multi-line codec can cause OOM if not configured carefully. Dead letter queues catch rejected events. This production Logstash pipeline handles both JSON and plaintext logs. It tries JSON parsing first, then falls back to Grok. The catch-all Grok pattern ensures no event is dropped. The date filter normalizes timestamps, and mutate adds metadata. Grok is the most important filter. It uses regex patterns to extract fields. Always include a catch-all pattern as the last alternative to prevent silent data loss. The date filter parses timestamps into the @timestamp field, which Elasticsearch uses for time-based queries. This cheat sheet shows common filter patterns. Grok extracts fields, date parses timestamps, mutate renames and converts fields, GeoWhip adds location data, and KV parses key-value pairs. Use conditionals to apply heavy filters only to relevant events. Effective Kibana dashboards start with an operational question. Build one dashboard per scenario, like incident triage or capacity planning. Saved searches load faster and are better for active incidents. Use KQL for its autocomplete and error resistance. This saved search shows 5 XX errors in the last 15 minutes. It's a simple query. Status code equals 500, filtered to the last 15 minutes. Import this into Kibana for one-click access during incidents. This is the same issue we highlighted at the start. Here's exactly why that happened. A pipeline processing 10,000 events per second had a 5% Grok failure rate. Each failed event tried 15 alternative patterns before giving up, wasting 500 regex evaluations per second. Unmatched events were silently dropped. The fix was to add a catch-all pattern, %GREDYDATA, log message, as the first alternative. This matches instantly, so the pipeline never evaluates other patterns on mismatched logs. CPU usage dropped 40%, and events were no longer silently dropped. Lowering the refresh interval below 1 second creates too many small segments, overwhelming the merge thread. This kills indexing throughput for negligible search freshness gain. Keep the default ones or increase it during bulk indexing. The article mentions Elastic Agent as a 2026 alternative. Ensure your deployment uses Elastic Stack 8x or later, as Elastic Agent requires Fleet Server, introduced in 7.13, stable in 8x. For older stacks, 7x, the classic FileBeat Logstash pipeline remains the recommended approach. The article describes the dead letter queue, but doesn't show how to replay rejected events. Use the dead letter queue input plugin to reprocess events after fixing the root cause, e.g., mapping conflict. This pipeline reads from the DL queue and reindexes to Elasticsearch. The article recommends 1030 GB per shard, but in production, shard size also impacts recovery time. A 50 GB shard can take 10+ minutes to relocate during node failure. For clusters with large indices, consider using index routing allocation total shards per node to limit shard count per node and avoid recovery bottlenecks. When logs stop flowing, triage in order. Check Elasticsearch health first, then Logstash Pipeline stats, then Kibana configuration. Use the Grok debugger in Kibana to test patterns. Inspect the dead letter queue for rejected events. Let's run through some common interview questions. What is an inverted index? A data structure mapping terms to document IDs for fast full-text search. How does Logstash handle multiline events? Using the multiline codec, which buffers lines in heap. Configure in FileBeat to reduce heap pressure. What are disk watermarks in Elasticsearch? Thresholds at 85%, 90%, and 95% that control shard allocation and index write availability. And a few frequently asked questions. What is the difference between FileBeat and Logstash? FileBeat is a lightweight shipper. Logstash is a heavy transformer. Why is my Kibana dashboard slow? Likely too many fields from dynamic mapping or too many buckets in time series. How do I prevent data loss in Logstash? Enable dead letter queue and add catch-all Grok patterns. To recap, the ELK stack is a data pipeline. Elasticsearch uses inverted indices for fast search. Logstash pipelines need catch-all Grok patterns to prevent data loss. Use dynamic, strict in index templates, and build Kibana dashboards around operational questions. Ready to go deeper? Up next, application performance monitoring, then distributed tracing with Jaeger, then SLI, SLO, SLA explained. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.